Assalamualaikum and hello. My name is Muhammad Benyamin bin Abdul Razak. My supervisor is Dr. Shafina Sobihana binti Sharifuddin. Thank you for to come today to watch my presentation video. Today, I would like to present my final year project, which is Arduino based floor cleaning robot using smartphone. According to a 2015 report by the Bureau of Labor Statistics, the average person over 15 years old spends 66 minutes per day dedicated to just cleaning. Nowadays, most people are working and they did not have enough time to do house chores during weekdays. And then they spend all weekend to do house chores every week. According to this graph, full-time employed women spend more than 20 hours on housework each week, while men spend more than around 10 hours. If these chores can be done automatically, people can save more free time on their weekend. Nowadays, tedious and boring house chores can be done automatically by robot. Through Internet of Things, robot can be connected to the internet and allow a communication of human-machine interaction. The readily in-market vacuum cleaner requires to be operated manually, which consume time and energy. An invention of automatic machine, such as washing machine, was created to do laundry automatically. Now, if the same concept apply for floor cleaning, we can say that the floor cleaning also can be done automatically if there is a robot that can make the job. The cheap automatic vacuum cleaner robot does not have automatic path movement. They do not have sensors to avoid collision, and most of all, they use the concept of bump into the wall and then it will turn. It will make the cleaning efficiency, efficiency of the cleaning is less effective because they do not have sensors to avoid the walls. Then, the cheap automatic vacuum cleaner robot also cannot be controlled remotely by user. So, since we have entered the IR 4.0, we can use the Wi-Fi and connect with our smartphone to control the vacuum robot. There are three objectives of this project. Number one is to build an automatic floor cleaning robot using Arduino Mega that can clean floor by vacuuming dirt efficiently. Number two is to develop a system that can control the robot wirelessly through smartphone via Wi-Fi. The last one is to develop a system that can control the movement of robot by add path planning for cleaning and sensors that can avoid obstacles and walls. Now, we will discuss the methodology of this project. This is the block diagram of this project. It has the Arduino Mega as the microcontroller, the three ultrasonic sensor, and also you have the DC motor gear and also the vacuum cleaner motor. DC motor gear we used to control the movement of the robot, while the vacuum cleaner was used to suck the dirt. The Arduino Mega will act as the brain of the robot, while the three ultrasonic sensor will use to sense the walls and obstacles. The Wi-Fi module used in this project is ESP8266. It allows the communication between user and robot through Wi-Fi. The flowchart shown the option of cleaning operation user can choose. After the robot is turned on and connect with Blink application successfully, user can choose which mode on their smartphone that they want to use. There are manual mode, random mode, and S-shaped pattern. User also can set a timer to make the robot move according to set of time. Manual mode allows the user to control the robot movement. They can make the robot to move in any direction, even the place that hard to reach, like really tight space. By using timer, user can set of time, and the robot will make the automatic movement based off the time that were set. This flowchart shows the movement for random mode. The random mode, as we can see, is when the robot sense any obstacles in front or walls, they will turn according to their own mind, based on the reading, or also based on the reading of left and right sensor. If the left sensor sense the close one, then it will turn right. If the right sensor sense the close obstacle, and it will turn left. Now, for this flowchart, it shows the S-shaped pattern. By using S-shaped pattern, it can cover most of the area the robot need to clean. When ultrasonic sensor detect obstacle or wall in front of the robot, it will be turning 90 degrees of its direction. Go forward a little bit and then turn 90 degrees more to make a U-turn. Based on the counter, it will determine whether the robot will move left or right. Now, this picture shows the prototype model of the robot. It shows that the front, left, and behind the robot are equipped with ultrasonic sensor. The chassis of the robot that were used was made by the sturdy arc-like material. It provides proper mount to motor that we're using, and also the other electronic component on top of it. And then the electronic component was covered by cardboards. The vacuum chamber that were used was placed behind the robot. Now let's move on to the result. There are tests that have been made to identify the best speed for the accuracy and consistency of ultrasonic sensor, and also the efficiency of vacuuming process. For the accuracy and consistency of ultrasonic sensor test, the ultrasonic sensor receives the distance between wall and robot and send the signal for robot to stop its movement if the distance between wall and sensor is equal or less than 20 cm. The table shows the result based on the distance from the wall to sensor in front of the robot. It shows the relationship between speed PWM of the robot and the percentage average error of the distance between walls and the three sensors. The speed PWM of 135 has the lowest percentage average error compared to other speed robot. Therefore, we can conclude that the lower the speed of the robot, the lower the percentage of average error. For the efficiency of vacuum speed test, the experiment was conducted on the fixed cleaning area with width of 1.8 meter and length of 2.2 meter. The robot will have moved in S-shaped pattern to collect the rubbish based on different speed. Its process has been set to repeat clean process for 5 minutes. Based on the result shown, the lower the speed has the highest number of pieces of rubbish collected. The speed of 135 has collected with 92 pieces, while the highest speed only managed to collect 38 pieces. Therefore, the lowest movement speed of the robot provided the best efficiency for cleaning process. Finally, this is the result of the Blink application. Blink application were used to communicate between smartphone and robot via Wi-Fi module. The figure shows the Blink interface of the robot, which has the switch button for S-shaped pattern, random mode, and on moto, and also have the joystick to control the robot manually. It also have the timer to set the time for the robot to turn on automatically. The robot will execute movement based on what input user made in this application. Now for the demonstration video that I will show you, I will explain the process. As you can see, there are the 4 different modes such as manual mode, S-shaped pattern, random mode, and also we can turn on the motor. We also have timer on this Blink application. Now I will show you how to turn on the motor just by pressing the switch on the Blink application. It will turn on, and then I will use the manual mode to control the movement of the robot manually to suck the dirt. As you can see, this is the manual mode. If I turn left, it will turn left. If I turn right, it will turn right. If I move forward, it will move forward. And then this is the S-shaped pattern. If I turn the switch button on the Blink application, the robot will make the algorithm of the S-shaped pattern. As you can see, the robot will move forward and sense the wall in front, and then it will make a U-turn. And then it will continue the cleaning process. Now if I choose the random mode, the robot will move accordingly and will move, and then it will sense the walls and it will detect the walls to avoid the obstacle. And based on the reading from the left and right sensor also, it will determine which turn that the robot want to make. Now for the timer, this I will show you the timer. As you can see, I set the timer at 9:20 AM, and then when the clock reached the 9:20 AM, without touching anything on the Blink application, the robot will move on its own. Because I already set the timer and we make the S-shaped pattern. As a conclusion, Arduino-based floor cleaning robot has been successfully designed and built for cleaning purposes that can vacuum dirt on the floor efficiently and can save user time and energy. With its sensor and path movement, it can make sure that the robot are able to clean efficiently. User also can have full control of the robot with Blink application on their smartphone. I hope that in the future, each Malaysia's household can adopt this technology to improve the quality of their life and time. Thank you for watching my presentation.